All right, these types of problems can be a little bit tough, these exponential decay problems. So I think the best thing to do is to draw a picture of what's being described. So we understand what exponential decay looks like. I'm gonna graph this. Every exponential decay problem looks something like this, where you have some initial amount and it decays over time and approaches zero. Okay, so let's decode this problem and try to plot some things on here to help us figure out. This is the same form as f of t equals f sub 0 times e to the kt, and we can see that k is negative 0.000121, which is handy, so we already know that value. So we don't need to call it f of t and f sub 0. We can use a and a sub 0. Okay, it doesn't matter what those letters are. All right, so prehistoric cave paintings were discovered in a cave in France. The paint contained 16% of the original carbon-14. Use the model to estimate the age of the painting. So the paintings were found some amount of time after they were made. So they were found down here at this moment in time. Okay, so this is this is the age we're looking for. We need to find that moment in time to figure out how long it had been since they were made. So all we do is we track this moment in time back over here, right? Because this is our time axis, and in this problem, let's see. Yeah, they're not specific enough. They should mention how time is measured, and in this case, it's going to be years. Okay. Um, Now we have to somehow get a number for on the vertical axis. This vertical axis could be the percent of carbon-14, since that's what we're measuring. Well, at the time that the painting was found, this moment in time, it only contained 16% of the carbon-14 that it had when it was made. And back here at this moment when it was made, at 0 years when it was made, it had 100% of its carbon-14. So now we just have to plug in the appropriate values for the initial amount of carbon-14. We're solving for t. T is the unknown, and we have to plug in the correct number for the current amount of carbon-14. Now I'm going to let you take it from there. That should be enough to get you started, given that you've already watched other videos and done practice problems. But hopefully drawing the picture can help you understand how to set up an exponential decay problem.